begin with, we are going to be talking about bounds. I'm now going to show you the method for bounds. The main thing you need to remember is upper half, downer half. To find the upper and lower bounds for the values 163 and 45.3, go upper half and downer half for each value. For example, 45.3 to the 10th of a litre, the upper bound for this would be 45.349 recurring, and the lower bound would be 45.25. Now, for 163.5 to a tenth of a kilometre, the upper bound would be 163.549 recurring, and the lower bound would be 162.5.
So, you've covered the basics. Now we're going to focus on finding the greatest and least possible values of a calculation. We are going to focus on the last column, the division column. Here is a worked example. The average fuel consumption of a car in kilometres per litre is given by the formula C equals D over F, where D is the distance travelled in kilometres and F is the fuel used in litres. D equals 163, correct to 3 significant figures, and F is equal to 45.3, correct to 3 significant figures. By considering bounds, work out the value of C to a suitable degree of accuracy. The question says, by considering bounds. So we need to work out the lower bound and upper bound of D and F. The upper bound of 163 would be 163.5, and the lower bound 162.5. The upper bound of F, 45.3, would be 45.35 and the lower bound 45.25. Now, we use our division column to calculate the greatest and least possible values. So, we take the upper bound of D, 163.5, and the lower bound of F, 45.25, and substitute it into the equation to get the answer 3.613259669. Then we have our least value. We take our lower bound of D, 162.5, and divide it by the upper bound of F, 45.35, to get the answer 3.583241455. So, now for the rounding. We have our greatest value and our least value. Starting with one significant figure, you will notice that both numbers 3.6 and 3.5 round to 4. Now on to two significant figures. Both numbers 3.61 and 3.58 round to 3.6. Now, three significant figures. Notice that the numbers that are rounded are different, 3.613 and 3.583. Therefore, the appropriate degree of accuracy is two significant figures. Therefore, the answer will be 3.6.
For marks gained within this example, you get 2 independent method marks, 1 method mark and 2 accuracy. To begin with, you get your independent method. For finding the upper and lower bounds of both values, for 1, it gains you 1 mark, and for doing the correct for the second, gains you 2. Now, the method mark. You need to highlight whether you are multiplying or dividing, and within this question, you need to divide. By showing this, you gain 1 method mark. Accuracy. You get an accuracy for doing the correct bonds in both greatest and lowest value. So here and here will gain you 1 accuracy mark. Now, within the question, it will ask you to give it to a suitable degree of accuracy. In here, it's 2 significant figures. By doing this correctly, it will gain you your last accuracy mark, gaining you 5 marks on an A to A star question.
Common errors. If you are given a length of a side to be 47 centimetres correct to the nearest centimetre, your first instinct may be that the lower bound would be 46.5 centimetres, which is correct, and that the upper bound would be 47.4 centimetres, which is incorrect, because technically 47.5 rounds to 48 centimetres. Therefore, the real upper bound would be 47.49 recurring, which would get you the marks. However, 47.49999 all the way to infinity may as well be equal to 47.5, which would get you the marks as well. This follows the method of upper half, downer half, which is not only easier to remember, but quicker to write and easier to use on a calculator if need be. So if you're given a bounds question in an exam, try and remember upper half and down a half.